All right, so let's start. So first thing I want to do is just a quick recap of our side-angle-side theorem, because the next congruence theorems that we're going to be doing are very similar to this. So if you can re-wrap your head around how exactly we went about proving this, then the ones that follow should be pretty intuitive, I think. So let's go over how we proved theorem, the side-angle-side theorem. And it was all based in the side-angle-side postulate. Do you remember what the side-angle-side postulate was? If I have two triangles who have a congruent angle, a congruent side, and another congruent side like that, the side-angle-side postulate gave me that this angle is congruent to this angle, and this angle is congruent to this angle. Okay? That was a postulate, not something we proved. That's an assumption. Side-angle-side postulate. Now we prove what we typically call the side-angle-side theorem, which talks about the congruence of triangles. This doesn't say anything about the triangles being congruent. When we use this postulate, we didn't even have a definition of what it means for triangles to be congruent. And then we gave it the obvious definition. These two triangles are congruent if all their segments are congruent and all their angles are congruent. Because we know what it means for segments to be congruent and angles to be congruent. So that was the side-angle-side postulate. So starting out in green is what we have given to us. If I have two triangles, A, B, C, and A prime, B prime, C prime, such that AB is congruent to A prime, B prime, A is congruent to A prime, and AC is congruent to A prime, C prime, then these two triangles are congruent. That's what the theorem is proving. Now we can use the side-angle-side postulate right out the door to get us most of the proof. Just using the side-angle postulate directly gives us that angle is congruent to that angle, and that angle is congruent to that angle. So all that remains to show is that BC was congruent to B prime, C prime. That's the crux of the proof. Everything else is basically just free, right? Yeah. Okay, so here's the way that we went about proving this. We said pick D prime such that C prime D prime is congruent to CB. Okay? D prime could be right here, D prime could have been right on B prime, B prime could have been over here. We don't know where it is. We just know it's on this ray, and its distance from here to here is congruent to that. That's all we knew about it, right? So we thought about this triangle, A prime, D prime, C prime, and this triangle, A, B, C, and notice that we can use the side-angle-side postulate again. So looking at A, B, C, and A prime, D prime, C prime, notice they have a side in common, an angle in common, and a side in common, right? So that gave us that angle A is congruent to this angle. So we had angle D prime, A prime, C prime is congruent to angle A, but we also had angle A was congruent to angle A prime. Right? Right. That's what we started with. We start with two triangles and A was congruent to A prime. Okay? Have I lost you so far? Just in the recap. Yeah. So that angle is congruent to that angle is congruent to that angle. Therefore, that angle and that angle are the same angle since they're on the same side of the line. Our existence postulate about angles is that given a ray, when we have a ray like that ray, there's one and only one angle on each side using that ray congruent to some given angle. So angle A prime and angle D prime, A prime, C prime aren't only congruent, they are the same angle. Right? So D prime is on this angle, A prime, and D prime is on this angle, C prime. So D prime is where these two angles intersect. Two angles intersect at, well, these two rays intersect at one point. They intersect at D prime, and they intersect at B prime. Therefore, D prime is B prime. You get the big picture logic there? If you can wrap your head around this one, the rest of them are easy. Okay. So that's a hard one. So if we have any questions about that, if we need to recap that again, it's worth it. So any questions at all about that? We got that? All right, so let's do the next one. So this next one is the angle-side angle. The angle-side angle congruence postulate. So we're saying if we have two triangles with two angles congruent and the side that is involved in both those angles congruent, then these two triangles are congruent. Okay?
Okay.
So that's what we're going to try and prove. We're going to try and prove that this is congruent to this. Okay? Now, we're going to use similar thinking. Well, maybe one. Let triangle A, B, C, and triangle A prime, B prime, C prime exist such that all these things up there, I won't bother writing it out. Not the then, all the things over here before the then. Such that A is congruent to A prime, AC is congruent to A prime, C prime, blah, 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 like my picture gives. Okay? So, big idea, maybe we'll talk big idea, then we'll go back and fill in. Big idea is, I'm going to do the same thing. I'm going to pick a point D prime so that this segment is the same long as this segment. So I'm going to pick D prime so that that's as long as that. Right?
Okay.
Now, think about, maybe I'll switch colors to help you see this. We're going to think about this triangle again, just like we did over here. Notice that this triangle, A prime, C prime, D prime, is going to be congruent to ACB by side, angle, side. Right? So then, we're going to get that this angle is congruent to A, which is given as congruent to A prime. So, D prime has to be on angle A prime, and D prime is also on angle C prime. Those two rays only intersect at one point, namely B prime. Therefore, D prime has to be B prime. Okay? So let's kind of erase, backtrack, and then I'll explain as I write it out again. So that's big picture what we're doing.
Does that give you your whole proof though? Or do you have to apply that step again? Because that still doesn't tell you that AB is congruent. So using our side angle side.
Then these angles were really the same angles, and we were talking about the same triangle, which is congruent by side angle side. Here, we'll write it out and we won't skip any steps. So start out with this. So my first step is to get that point D prime. 2. Let D prime on C prime B prime such that D prime is on the same side of C prime as B prime. Right? So D prime, we don't know where it is. We're just going to draw it for the sake of helping us think. Somewhere over there. Right? Oh, and I didn't finish making it congruent. Let D prime on that such that that is on that, and we want C prime D prime congruent to CB. Good? So that gives me, oh, I forgot to erase those double lines. But that gives me that segment congruent to that segment. And we know that we can pick a segment of any length, we can construct that on a ray, right? In fact, we can construct two, one on either side of a point. That was the existence postulate for segments. Maybe backtrack a little bit. First postulate for segments, 3-1 or whatever it is. I think it's the first, might be the second. It says, if you give me any segment, and you give me any point, then I can construct a point on either side of that segment such that that's congruent to that and that's congruent to that. Right?
Okay.
So here's a segment. I'm guaranteed on a particular side of C prime, I can find a point, namely D prime, such that that segment's congruent to that segment. Good? So now we've got the point. So, 3. Now we're going to consider this triangle if we were to think about connecting it like that. And notice that if D prime were clear up here, we'd still have a triangle. So regardless of where D prime is, we can create a triangle with 3 non-collinear points. All right. So 3, observe that triangle, let's see how we want to name it, A prime, C prime, D prime. A prime, C prime, D prime is congruent to triangle ACB, triangle ACB by side, angle, side. Good? Okay. 4. Then this angle, this bottom left-hand angle of this triangle, has to be congruent to the bottom left-hand angle of this triangle. Then angle C prime, well, I'm going to use A prime to reference the whole exterior angle.
Okay.
So, of course, I don't know if this one's exterior or not, so maybe I should be careful and never actually call an angle A prime. Of course, I already did call an angle A prime up here, so A prime was one associated with the original triangle. Anyways, so then angle C prime, A prime, D prime is congruent to angle A, right? If those two triangles are congruent, and to see how it works, maybe I'll spell out A this way, CAB. You'll notice that the ordering of those corresponds to the ordering we gave here. That's very important when we talk about congruent triangles.
Okay.
So we said CA, D, and B, so C, A, D, and B. Second, first, third.
Okay.
Do you understand why that's important? So maybe we'll push pause on this for a second because this is an important point to get into your head. So let's say that I have A, B, C, and then C prime, B prime, A prime. And let's say that I know that that angle is congruent to that angle, that side is congruent to that side, that angle is congruent to that angle, this side is congruent to this side, this angle is congruent to this angle, and this side is congruent to this side.
Okay.
Obviously, those two triangles are congruent, right?
Right.
But if you were to then write the statement, triangle ABC is congruent to triangle A prime, B prime, C prime, this statement would be false. Order matters. When I say that triangle ABC is congruent to triangle A prime, B prime, C prime, what am I saying? I'm saying segment AB is congruent to segment A prime, B prime. Segment BC is congruent to segment B prime, C prime. Segment AC is congruent to segment A prime, C prime. Angle ABC is congruent to angle A prime, B prime, C prime. Angle BCA is congruent to etc. Picking all the angles to talk about, all the angles of segments we can talk about in this order on this, we're saying they're the same on both of those. So I'd have to change my lettering here. I'd have to say triangle CBA is congruent to A prime, B prime, C prime. Then that becomes a true statement. So the order matters. Independent of the picture, if I just say this triangle is congruent to this triangle, you should be able to tell me all the congruence relations. Which segments are congruent to which ones, and which angles are congruent to which ones. So ignoring our picture, if I look at these, it gives me that information. That's the point I was trying to make sure we got clipped. Does that make sense?
Yeah.
Now the rest of my class is here. Deborah, one job.
I thought you were so like, no.
That was last week.
Did you say want to sleep over? I'm gonna sleep out tonight.
Oh shoot, that's pretty loud.
Feels great.
They're passing. Talking about the four-wheeler or motorbike out there,
Yeah.
it feels great.
He said it's pretty loud. And I didn't want you to shut the door, so I made the statement. It feels great.
Okay. Alright, so since all of you just got here, now I need to decide, do we go back or do I just continue? And lose most of the class?
We did this last time.
No, you didn't do this.
Yeah, we did.
No, you didn't.
Go do a
I know
problem.
everything you've done. Alright,
Let's see if you know.
so I'm going to do a recap for all you girls that just came in, and we'll play catch up real quick. So first thing I wrote over here was what we ended with last time. what we ended with last time was our first congruence relation for triangles. Not congruence relation. Our first theorem that we use to prove triangles are congruent, side angle side. Okay? So let me just remind you, big picture, what we did, because we're going to use similar types of thinking for our other congruency proofs. So if you can wrap your head around this proof, then this other stuff is going to be a lot easier. Okay? You with me?
Yeah.
You still dreaming about other stuff?
Yeah.
All right. So here's what it said. It said if I have two triangles, green's what was given, blue's what I added. So if I have two triangles A, B, C, and A prime, B prime, C prime, such that A is congruent to A prime, AB is congruent to A prime, B prime, and AC is congruent to A prime, C prime, then these two triangles were congruent. Okay? That's what we were proving. So the first thing we said is right out the door, we knew that angle B prime and angle B were congruent, and angle C prime and angle C were congruent. How did we know that?
Because of the side-angle postulate, or side-angle-side postulate.
The side-angle-side postulate. Remember, it's a little bit confusing when you first come across this. We had a side-angle-side postulate, and we use that to prove our side-angle-side theorem. So our side-angle-side postulate, if you remember, it says if you have two triangles, and you know that this angle is congruent to this angle, this side's congruent to this side, and this side's congruent to this side, then these angles are congruent, and these angles are congruent. Do you remember how we proved that?
Yes.
You do? You shouldn't, because we didn't prove it.
I know.
It was a postulate.
Yeah.
There's no proof of it. We assume it's true, and we continue in our geometry.
But we proved the theorem.
We prove this, but we use this to prove this. This, there's no proof of. It's a postulate. Okay? All right. So yeah, first thing we did is we used this postulate. We said using that postulate, that angle and that angle have to be congruent. Right? And so the only hard part of the whole proof was trying to prove that BC is congruent to B prime C prime. That was the crux of the proof, right? So here's where we actually have to start thinking and get a little bit tricky. We said, all right, pick a point D prime on this side of the triangle so that this length is congruent to that length. C prime D prime is congruent to CB. And then we were going to prove that D prime is in fact the point B prime. Okay?
Yeah.
So we drew our picture like it wasn't that point, but it turns out it is really the same point. That point and that point are really the same point. So here's what we did. We said pick D prime on this side so that this length is the same as that length. Okay?
Yeah.
And then we can use our side-angle-side postulate again. Notice side-angle-side corresponds with side-angle-side. So looking at this triangle that has the blue line right here, the side-angle-side theorem or postulate applies to this triangle and this triangle as well. So I know that this angle is congruent to this angle. But I know that this angle is congruent to this angle. Not a contradiction. It just means that this angle and this angle are the same angle.
Oh, right.
That's what it means. And so D prime is on this angle, which is the same as this angle. So D prime is on the ray A prime B prime, and D prime is on the ray C prime B prime. So
And it's
D
only
prime
1 point.
is where the two rays intersect. Two rays only intersect at one point. We know one point that they intersect at is B prime. We know they also intersect at D prime. They only intersect at one point. Therefore, B prime and D prime are the same points. You follow the logic there?
Yeah.
It might have been a little confusing with all that without the words right now, but if you kind of see big picture what we did, then watch me go through this one. I think some of it will click with you again. Okay? So, let me erase on this picture real quick, and I'll give you a big picture of what we're doing again, and then I'll walk you through the proof so far. So the next theorem that we're proving isn't side-angle-side, it's angle-side-angle. That's how we usually reference it. So we're saying if we have two triangles that have an angle, and the side in between those two angles in common. So that angle is congruent to that angle, that side is congruent to that side, and that angle is congruent to that angle. Then the two triangles are congruent. That's what we're trying to prove. Okay? Are you with me? All right. So we did a similar trick that we did down here. We said, look, we're going to pick a point D prime. We don't know where this point is. So that this segment is the same long as this segment. Right? Okay. So, maybe I should be doing that in blue. Blue is what we're adding. So I'll do it in blue. So I pick a point D prime so that this segment is congruent to this segment. So now, if you pay attention to this triangle, it has a side in common with this triangle, an angle in common with this triangle, and a side in common with this triangle. Right? So by side-angle-side theorem, by the side-angle-side theorem that we just proved over here, that smaller triangle and this triangle are congruent. Therefore, this angle and this angle are congruent. But we already know that this angle is congruent with that angle. So that's congruent with that is congruent with that. So these two angles are congruent. They're on the same side of this ray, therefore they're the same angle. Make sense? Okay, so that's big picture of what we're going to do. So erase, erase, erase. And let's recap the proof so far. So the proof so far. So I said start out, let A, B, C, and A prime, B prime, C prime be triangle such that that, and that is true. Okay? That's line 1. Line 2, I said let D prime be on the ray C prime, B prime, such that, or on the line C prime, B prime, such that D prime is on the same side of C prime as B prime. So D prime and B prime are both on this side of C prime. Okay? I don't know if it goes D prime, B prime. I don't know if it goes B prime, B prime. I don't know if they're the same point. I just know they're both on the same side of C prime. Does that make sense so far?
Yeah.
Okay. So I picked D prime to be on the same side of C prime as B prime, such that C prime D prime is congruent to CB. And that's using our existence postulate with line segments. Going back to line segments, we knew that if I give you a line segment and I give you a point on a line, then there are 2 points and only 2 points on either side of this. There's a point over here and a point over here, such that that's congruent to that and that's congruent to that. So on a particular side, I'm guaranteed that there's a point D prime, such that that is congruent to that. Here's my given segment, here's my congruent segment on a particular side of C prime. Good? And that's as far as, oh, that's not as far as we got. So I put that point D prime there, and then we're going to look at this triangle. And I say, observe that triangle A prime, C prime, D prime is congruent to triangle ACB by side, angle, side. Right? So that gives me that angle C prime, A prime, D prime is congruent to CAB. And that's when you guys walked in, when we were having a conversation about the order that I named these things matters. Okay? You should know just by the order I put the letters in here for my congruence, which angles are congruent to which angles and which line segments are congruent to which line segments. Right? Just make sure you follow the same order in however you pick them. Does that make sense? Okay. So now we have that this angle is congruent to this angle, which is also congruent to that angle. So then that is congruent to that is equal to A. That's just another name for angle A. Is congruent to angle A prime. You follow that?
Yeah.
Okay. Let's erase some of our picture. Do. So 5. Then D prime is on ray A prime B prime, or line A prime B prime, right? maybe I'm skipping a step there. Maybe you want this. Then angle C prime, A prime, D prime is equal to angle B,
No.
or A prime. Sorry.
Yeah.
Yeah.
And then we know that because, why?
Guys, C prime, A prime, D prime is congruent
You
to
say it there.
angle A.
So the same thing that we had with segments. I said if I gave you a segment and I gave you a point on a line, then there's only two segments on this line, namely that one and that one, using that point so that these are congruent, right?
Yeah.
We had a similar theorem with angles. Our theorem with angles, we said, look, if I give you an angle and I give you some ray, then there's only two angles that you can do, one on either side, such that those are congruent to the given angle. Right?
Yeah.
So, maybe put some explanation here. Then that is equal to that since B prime and D prime are both on the same side of AC, or A prime C prime. Does that make sense?
Yeah.
Since B prime and D prime are on the same side of line A prime C prime. Okay? So then D prime is on line A prime B prime and D prime is on line C prime D prime, or C prime D prime, we could also name that line, right?
Yeah.
So 6, then D prime is on A prime B prime and on C prime B prime, and so D prime equals B prime. You good with that?
Yeah.
Yeah.
Okay, so now we've got that those are the same points. Right?
Yeah.
So 7, then triangle, let's see, how did we list it here? Then triangle ACB is congruent to triangle A prime, triangle A prime C prime D prime is equal to triangle A prime C prime B prime, because D prime and B prime are really the same point. And we're done. We proved that two triangles are congruent. Any questions? Is that good? Is that easy? You can write that out and do it yourself now? Huh?
Maybe.
Maybe? I think if you can figure out how to draw the picture, you can prove it. Everything else is just kind of like filling in the, well, yeah, it's filling in the logic, but filling it in isn't as hard. So you're good with that? You think you can prove that now? No problem?
Problem.
Problem?
No problem.
After you erase them.
Let's go over big picture one more time without all the words. We'll just draw it out. We've got two triangles. And we know that this angle is congruent to this angle, this side is congruent to this side, this angle is congruent to this angle. Right? That's what we know. So we pick a point on here so that this is congruent to this,
So we could do a side-angle-side.
which gives us that this triangle is now congruent to this one with the dotted line, which gives us that this angle is congruent to this angle, which is congruent to this angle, which forces these two triangles to be the same triangle.
Yeah.
And so they're congruent by side angle side.
Okay.
That's all we did, right? Okay. Our next congruence theorem, who can guess what it is? And what number is it?
Side, side, side.
Theorem 6.7. Oh, did we skip a theorem?
Yeah, I need to do 6, 6.
Theorem 6.6. Okay, so Theorem 6.6 is, we've already done one very similar to it. So we already proved if I have an isosceles triangle, if that is equal to that, then this angle is equal to this angle. Now we're going to do the reverse. We're going to say if that angle is equal to that angle, that side's equal to that side. Okay? And the way that we do this is, do you remember how we proved that? How did we prove it? What was our big trick?
We made 2 different triangles.
We made a triangle on top of itself.
Yeah, so we called this triangle ABC, and then we called that also C prime, we called that also B prime, and we called that also A prime.
Yeah. I
Right?
remember this.
And we made it congruent to itself.
Not congruent, we didn't have congruence at the time.
Oh.
So we knew it was an isosceles triangle, right?
Yeah. So those 2 sides are the same length.
So those 2 sides were the same length, so we have these 2 labeling of the points to show that that and that are congruent. Do you remember it?
Yeah.
So we're going to use a similar idea for this exact same thing.
Okay.
So let's get our labeling. I did the exact same labeling as that. So, I guess it doesn't really matter what we call it. I'm going to call it B prime C prime. I'm going to call that A prime A, or A prime. And then we have C equal to B prime. We're given that, and then that side's going to be the same, and we're going to use our congruence. So now we'll write out everything. But I think you see big picture what we're going to do, right? So, here's what the theorem actually says. It's theorem
6, 5.
6.5. 6.5?
No, it's 6, 6.
6. So it says if angle B is congruent to angle C on triangle ABC, then AB is congruent to AC. Okay? And the other one just did the converse, or the converse of this. So, the big picture is exactly what we talked about here. So 1, let triangle ABC exist such that angle B is congruent to angle C. Two, I don't know what to say, construct triangle A prime, B prime, C prime. No, we're going to swap these 2.
Oh, yeah.
C prime, B prime equal to triangle ABC. So basically relabel the points so that A corresponds to A, C prime corresponds to B, and B prime corresponds to C. Right?
Yeah.
So then we have observe that angle, we'll start with angle B. Angle B is congruent to angle C by definition, or by what was given, that was given, is congruent to angle C, which is equal to angle B prime. So B is congruent to B prime. For observe BC is congruent to B prime, C prime, because they're the same segment, right?
Doesn't matter.
No, you'd go C prime, D prime.
Doesn't matter the order for the segment.
Doesn't matter the order. Segment AB is congruent to segment BA. And that was part of our first postulate talking about congruence of segments. And then finally, 5, observe that angle C is congruent to angle B is equal to angle C prime. Right? Then triangle, let's see the order that we did. We went from, oh, we didn't use A to name it. So triangle ABC is congruent to triangle A prime, B prime, C prime by side, angle, side.
Isn't
No.
it A prime, C prime, D prime?
Yeah, you're right. Then, therefore,
We had B congruent to B prime. We had C congruent to C prime. And we had BC congruent to B prime, C prime. So that angle, that side, and that angle.
That's not side angle side, that's angle side angle.
Oh, did I say? That's what I meant, sorry. Now I see the confusion. Angle, side, angle. The last theorem that we just did. Not that theorem, but the one we erased. 6-5, yeah. Right?
yeah.
Well, guess we're not done yet. 7, therefore, looking at this, what do I know? I know that that segment's congruent to that segment, that segment's congruent to that segment, and that segment's congruent to that segment. Because they're congruent triangles. But all we care about is that AB is congruent to A prime and B prime. Therefore, AB is congruent to
AC.
A prime, B prime. This does not tell us that AB is congruent to A prime, C prime.
That's what you're trying to get. Yeah.
Oh,
No.
is congruent to A prime, B prime is equal to AC. Thank you. Right?
Yeah.
A prime, B prime, and AC are the same thing. A prime, B prime,
No.
oh, A prime, B prime, and AC.
Yeah.
Same segment. So, that gives us that side is equal to that side.
Yeah.
Okay. Now we can move on to side, angle, side. Or- Side, side.
Side.
I just like saying side, angle, side.
Obviously.
Obviously.
Obvious.
Okay. Side, side, side. What theorem is this?
6, 7.
Theorem 6, 7. If AB is congruent to A prime, B prime, AC is congruent to A prime, C prime, and BC is congruent to B prime, C prime, then triangle ABC is congruent to triangle A prime, B prime, C prime. Prime, prime, prime. Sorry, kind of got smaller for a minute. Alright, once again, we'll start by drawing the pictures, show a big picture how we're going to do this, and then go from there. I'm going to want to draw not a nice sausage triangle, so it's obvious which sides correspond to which to help make it intuitive. So there's one of our triangles.
Unequal atom.
There's another one of our triangles. Okay. Big picture what I'm going to do, let me give them names. This one can be A, B, C. This one can be A prime, B prime, C prime. Okay. And what do we know? We know that is congruent to that is congruent to that, and that is congruent to that. Okay? So this one's a little bit different than the other ones. So, first, what I'm going to do is I'm going to construct a triangle down here, congruent to this triangle, and then show it's congruent to this triangle. And then congruence is transitive, so that will be congruent to the triangle I draw down here is congruent to this triangle. Okay? That's what I'm going to do. So first thing I'm going to do is I'm going to say, using this ray, A prime, C prime, construct an angle on this side so that this is congruent to this. Okay? Then I'm going to say, pick a point, call it D prime on that ray, so that this, now I'll do a line here, so that this side is congruent to this side.
Yeah.
See what I'm doing so far?
Yeah.
So now, if you just finish the triangle by filling that in, we have, looking at this bottom triangle, I was calling this D prime, let me write that so you can tell, D prime. So we have, using side, angle, side, side, angle, side, that this triangle is congruent to the triangle we drew down here, okay? You follow that? So we got this one congruent to the one we drew down here. Our next step is to show that this one's congruent to this one, okay? The way that we're going to do that is we're going to think about connecting the lines like that.
No.
And
Why wouldn't you do it like all the other triangles?
Yeah, why don't you sit the other way?
oh, by the way, when we show the bottom one's congruent to this one, that also gives us that this side is congruent to this side. Okay? So now, then we draw this line. Now we need to show that this triangle is congruent to this triangle. The way we do that is isosceles triangles. Look at this triangle as these two sides equal, which means that this angle is equal to this angle, right? And then look at this isosceles triangle, which gives us that this angle is equal to this angle, right? And then the sum of those two angles is equal to the sum of those two angles. So this whole angle is equal to this whole angle, or congruent, I mean. So then by side, angle, side, this triangle is congruent to this triangle. Okay? So I constructed this bottom triangle to be congruent to this top triangle, and then I showed that this one's congruent to that bottom one. So we'll do all that again, but that's big picture what we're going to do. Good?
Yeah.
Okay, so let's hit reset. Reset, reset. And redraw this triangle. Maybe I should have done my prime one up there and the one with regular letters down here so I didn't have to keep
Did you
using
find a
primes.
lot?
Oh well, it's only one more letter that we add. Okay. That, 3 there, 2 there. So 1. Let triangle ABC and triangle A prime, B prime, C prime exist such that all their sides are congruent like we stated up there. Good?
Yeah.
Okay. So, now remember our first step. Our first step was construct an angle down here congruent to angle A.
Yeah.
Right? So, how do we want to say this? Maybe we'll use 2 points. So let's call it, we'll use our D prime here and E up here. So let D prime exist. Maybe that's too confusing because we're creating an angle. I think you'll follow me. So let D prime exist such that angle C A prime D prime is congruent to angle A, and D prime is on the opposite side of A prime C prime as B prime. That's a C prime. So basically what I'm saying is, let D be one of the points that's on the angle that makes that congruent to that. I'm just trying to come up with a way to name this angle. So I'm just creating D prime so I can name this angle. You good?
Yeah. You need to fix that then. Number 2, it's C prime. It's just such that C prime, A prime.
Thank you. Yeah, everything's primes down here. Okay? So I'm guaranteed that that angle exists, right? And I'm just using D prime as a point to name on this side so I can name the angle. Okay. So now we have this angle is congruent to that angle. Next, we need to find a point on this angle that makes this side congruent to that side, right? I'm trying to construct a triangle down here congruent to this triangle. That's what I'm doing. So, 3. Let, what's after D? Let E prime on A prime D prime such that A prime E prime is congruent to AB and A prime.
No, C prime.
I'm not going to bother specifying, and it's on the same side of A prime as D prime. Okay? But that's why I was about to write and decide not to. Because I don't want to lose you in that verbiage anymore. You see what I'm saying?
Yeah, I thought you were going to say that once you draw a line between C prime and A prime, that it'd be congruent.
I'm just saying, pick the line on this, pick the point on this angle
Okay.
that makes this distance the same long as that distance.
Okay.
Right? So now we know that is congruent to that. And now we can finish drawing this triangle in here. Right? Just to help us think. So now look at it. That side's congruent to that side. That angle is congruent to that angle. That side's congruent to that side. Therefore, these two triangles are congruent. Good?
Yeah, but you got
And so since they're congruent, I now know that that side is congruent to that side. Okay? So now let's write that out. Observe that triangle C prime, A prime, E prime is congruent to triangle B prime, or BAC, right? Does everyone see that? Don't make me yell. What's wrong with that?
Oh, everything's wrong with it.
It's not.
It's not.
It's the wrong order. It's congruent to triangle CAB. That's what we know. All right. So observe that that triangle is congruent to that triangle, comma. So angle, or not angle, so E prime C prime. So E prime C prime is congruent to BC. Right? Whatever's in the third position is the third and first is congruent to whatever's in the third and first. Whatever that segment is.
Yeah.
Order matters. Okay. And we already wrote that, right? E prime C prime is congruent to BC. Okay? So we've got this triangle is congruent to this triangle. Now we need to show that this triangle is congruent to this triangle. And we're done. Let me move these 3 lines so that we can draw a line there. Just pretend that those were over there. So the way we're going to do this now is we're going to think about splitting it like that into 2 isosceles triangles. Okay? We got the isosceles triangle this way and the isosceles triangle that way. So that angle is congruent to that angle, and that angle is congruent to that angle, so the sum of those is congruent to the sum of those. So that whole angle is congruent to that whole angle, so those two triangles are congruent. You see the big picture thinking? Yeah, Laura? Yeah? Okay. Alright. So 5. Observe triangle E prime, A prime, B prime is what?
Congruent. Isosceles.
It is isosceles, comma.
I couldn't think of the word.
So angle A prime, E prime, B prime. A prime, E prime, B
Angle
prime
A.
is congruent to angle
A.
A prime, B prime, E prime.
Oh.
Prime, prime, prime.
You
You stop doing that.
that.
Yeah, I need to say that this angle is congruent to this angle.
Fine.
The next time you say that that one's congruent to that one.
How boring.
6. Observe
CBE.
triangle C prime, B prime, E prime. That's what you want to say. C, B, E prime, prime, prime is isosceles. So
Angle CBE
angle CBE
is
all prime is congruent to
CEB.
CEB. Good.
Prime, prime, prime.
Prime, prime, prime. Okay. So then we got that's congruent to that. Right?
Yeah.
So then we use, what postulate was it?
Angle, side, angle.
Addition
Side
of
and
congruent angles thing.
Yeah, what was it? Whatever number it was. Therefore, angle A prime, B prime, we'll just say B prime. B prime is congruent to
E prime.
angle E prime.
Which is congruent to angle B.
Then triangle A prime, B prime, C prime is congruent to
ABC.
triangle A prime, E prime, C prime
It's congruent to
is congruent to
ABC.
ABC, triangle ABC. And we're done. All right, how about that one? Think you could do that one?
Yeah.
Is that one the easiest one? Great.
A lot of writing though.
Yeah, a lot of writing. That's what happens when you try to be exact with what you're saying. So, that was side, side, side. So now we have those three congruence terms, which enable us to do a lot.
Yeah.
Now our next proof is going to be that proving that right angles exist. So we've already defined what a right angle is. We've already said a lot about if a right angle exists, then blah, 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 blah. But we've never actually proved that in our geometry, a right angle exists. Oh shoot, I missed a point. In that proof I did. In the proof we just did for side, 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 I drew my triangle like this, and then I drew the one underneath it to make two isosceles triangles, right? Well, the triangle could have looked like this, in which case when I draw the one under it, I don't get two isosceles triangles.
You get one.
I just get the one. Okay? And then, so in that case it's easier, right? And then last case, my triangles could have looked like this.
Which are still two.
In which case, we can think about this line here. And then we use the fact that equals subtracted from equals or equal. Because then you have that isosceles triangle, that isosceles triangle. And so the big angle minus the little angle leaves equal remainders. So that's how you would have proved it for those other two cases. I only proved one case. But it's almost the exact same thinking. You see how you would do it? Instead of adding them together, you're now subtracting. Okay. All right. So now let's prove that a right angle exists. Kind of a weird thing to do. What's the number on it?
610.
Oh, it wasn't a theorem. They just had the proof in there. It's not a definition or a theorem. They just proved it, and they didn't give it a name. Oh, is it an exercise? Is that right? I don't think it's an exercise. Anyways, we'll just do it. Who cares? So, we need to prove that a triangle actually, or not a triangle.
Right angle.
We need to prove a right angle actually exists. We'll start by saying that. Prove a right angle exists. Okay, what do we know exists in our geometry for sure?
Point, a line, 3 points.
Isosceles triangle.
3 points. We know that we have 3 non-collinear points. We're guaranteed we have that at least, right?
Yep.
So I can start out with 3 non-collinear points. Whatever. And I can draw a line through 2 of them. I know at 2 points I have a line, right? And then to follow how he labels it, what does he call which? He calls
The top one, A.
O, A, and C? No.
B.
And B. So this is O, this is A, and this is B. Right?
Here.
Maybe move O over there. So, that now gives me this angle. Now what can I do? If I have one angle, what else can I do? I can draw another one right down the other side, right? So I can draw an angle there so that that's congruent to that. I know I can do that. I can also, on this, from this point, I can find the point A prime so that this is the same big as that, right? Okay. And now I'm trying to show that basically I want this and this to be my right angle. Hopefully that's pretty obvious. How am I going to argue that those are right angles?
Because if they're added into a straight angle, then they're right.
Supplementary.
If the complement of it is congruent.
The supplementary.
What's the definition of a right angle?
If the supplement of the angle is congruent to the angle.
Right. If an angle is congruent to its adjacent supplement, or supplement, I guess you could just say. If an angle is congruent to the supplement, then the angle is a right angle.
Yeah.
So we need to show that this angle is congruent to the supplement.
So, side, angle, side.
Side, angle, side. Perfect. Think about using this side that they share in common. Side, angle, side, side, angle, side. Those 2 triangles are congruent.
Wait,
Therefore,
that
this
one-
angle is congruent with this angle.
Yep.
Those are supplementary angles. Okay? Should we go over that one more time? You ready to restart? Uh-huh. If you're gonna bag. So 1, we knew that 3 points existed, 3 non-collinear points, right? 3 non-collinear points. We knew 2 points defines a line segment, or a line, right? And we could also make that line. Those 2 rays together create an angle. Once we have an angle on one side of a ray, we're guaranteed that there's an angle on another side of a ray. Once we have that point, that line segment, we're guaranteed that we can create another line segment here. Then we drew that line down. We knew that was equal to that. We knew that that was equal to itself. Therefore, these 2 triangles are congruent. Therefore, these 2 angles are right angles.
Yep.
That's what we did. Now in our picture, we haven't handled all the cases. So there's 2 more cases that we need to handle. We need to handle the case where the point's right above it. So that when we draw our angle, it just comes down here like that.
Oh, it's the same thing then.
Well, yeah, that one's even easier. So I already have that angle congruent to that angle and that's straight. Ta-da, we're done. And then the last case we needed to handle was the point was over here and not between them like we drew here. Right? Still do the exact same type of thinking. We've got our angle. You can construct this angle if you want, or you can just flat out get another point over here and now talk about this angle, and then you can come down and do the same thing again. Either way. What's up?
What makes it supplementary?
So if the two angles together make a straight angle,
Oh.
then they're supplementary. So if I have two adjacent angles, and the rays that they don't have in common are a straight angle, then they're supplementary angles.
How'd you know that A prime is a straight angle?
You're saying right here?
Yeah.
It's a line. I created a line. Straight angle is one. So I drew a line
We already went through that.
through both those points. Now I just need to make sure that those two angles were congruent. That make sense? Okay. So that was a little side note about right triangles actually exist. And now let's do triangle inequalities, or angle inequalities. So going back to the last inequalities we did, what were the last inequalities we did?
Segment.
Segments, right? What did it mean for me to say that segment AB was less than segment AC?
That there is a point.
On AC.
There exists a point B prime on a, I don't even need to see that.
AC
There exists
where
a point B
ABC.
prime such that
ABC.
AB is congruent to A prime B prime and A prime,
A.
oh, oops.
And
Did I do that
ABC.
backwards? Not this. That's supposed to be prime. Because we're not using the same points.
And A prime.
So AB is congruent to A prime B prime and A prime B prime C prime. Right?
Yep.
So now we're going to come up with a definition for an angle to be less than. So, do you all see the picture that corresponds with this already?
Yeah.
Yeah.
We don't need to draw that out.
Yeah.
So now we're going to draw a picture with angles to help you see what it means for one angle to be less than another. So when I say that angle A is less than, try and do my less than symbols more like that so it doesn't look like an angle sign. Angle B, what does that mean? It means that if I have, so here's my angle A. Here's my angle B. It means that I can come to my angle B, I can pick one of its rays, from that ray I can construct an angle congruent to angle A. Maybe do this in dotted line to,
On the interior of angle B.
and the other side ends up on the interior of angle B. So if when I come to this ray right here, and I'm going to draw an angle congruent to this angle. I'm going to draw an angle congruent to angle A, so that its other side is on the same side of this ray as angle B's other side. If it lands on the interior, then angle A is less than angle B. If it lands on the exterior,
Angle A.
then we would say angle A is greater than angle B. You see the two ideas?
Yep.
Now notice it's similar to when we did our line segments lesson. We had one up here, and then we came down onto the other segment and added points. Similarly, we're going to have one angle here. We're going to come to this angle and add rays. Okay? And the same way that just because AB was less than AC didn't mean that we get to automatically assume AC is greater than AB. Because those talk about different points on different things, right? Do you remember doing this proof? Showing that if this is true, then this is true?
Yeah. Yeah.
Because the way that we showed that is we could basically come up here and draw a point there, and then it works. Do you remember that? So we're going to do this exact same type of proof, except for now we're going to do it with angles. So we're going to show that if angle A is less than angle B, then angle B is greater than angle A. And that's going to involve using our picture here to create a picture here. Good? Alright, so let's jump into it. What?
He did it.
I did it. Oh, whistled? Yes, I whistled. Let's see. Da, 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 da. Oh. Did I skip a definition? Oh, I skipped one part of the definition. So we were talking about definition 6.5, which tells us about one angle being less than another angle, or one angle greater than another angle. There's one last thing I missed. It's if angle A is a straight angle and angle B isn't, angle A is greater than angle B. In other words, the biggest angle you can make is a straight angle. Any angle that's not a straight angle is smaller than a straight angle. Okay? That might go counterintuitive to what you did in algebra, right? Because you might be thinking, well, this angle is bigger than a straight angle. No, not in our geometry, because we don't reference an angle like that. All an angle is 2 rays. You don't get to say, no, I want you to think about it this way. We don't have a way of saying that in our geometry.
Yeah.
So, that's the third postulate, or the third part of the definition. So we define what it means to be less than, what it means to be greater than, and the third part is a straight angle is the largest angle. If an angle is not a straight angle, it's less than a straight angle.
Yeah, but
Does that make sense?
for our graphs, we need to say, make a 270 degree angle.
We don't know what a degree is.
And it's complement, supplement.
What's the supplement of a 270
Oh, no.
degree angle?
It's the rest of it.
All right. So be aware of that. And let's jump into this proof. Huh? So this is theorem 6.8. And it says, if angle B is less than angle A, then angle A is greater than angle B. Okay? So let's draw the picture, go over how we're basically going to do this, and then do it. So here's the picture I'm going to use. Here's my angle A. We won't mark anything up yet. There's A. We'll draw B so it's obviously smaller. Now this is just going to help me think, so you're going to have to let me draw A prime real quick. Okay, so kind of ignore my A prime and B prime for a second. Just pay attention to the A and the B. So I'm going to start out with angle A and angle B such that angle B is less than angle A. Now what does it mean for angle B to be less than angle A? It means I can draw an angle congruent to angle B right here so that its other side ends up on the interior of angle A. That's using the definition of angle B is less than angle A. You good?
Yeah.
Okay. And then I'm going to come over on this ray And I'm going to construct angle A prime congruent to angle A. The big crux of this proof is proving that this ray is interior to this angle. That's what I'm trying to prove. If I can show that this ray is interior to this angle, then I can now say angle A is greater than angle B. So angle B less than angle A gives me that this ray is interior. Angle A being greater than angle B means that this ray has to be interior. That's what I'm trying to prove. This one's interior to this angle. You see big picture what we're going to try and do? You see it, James, or is everything in the way?
Just Robin, not everything.
Just Rhoda, not everything. Looks like Rhoda's not the whole world. Shocker.
Aren't we proving,
I guess there's more in the world.
Are we proving that that dotted ray is on the exterior, not the middle rays in the interior?
Same thing, right?
Whoa.
If this is exterior to this angle, and this side's in common, then that just means that that if I take a point here and a point here, then a point here intersects it. But you're saying the definition uses the actual word exterior instead of interior?
Yeah.
Yeah. So showing that this is exterior to this is logically equivalent to showing that this is interior to that. But yeah, if that's what the definition says, then we need to show that this is exterior to this. Okay? You see a big picture of what we're going to do?
Yeah.
All right. So here's how I'm going to go about doing that. I'm going to start out by picking 2 points on either side of this angle. Doesn't matter what 2 points. Pick a point here. What do we want to call it? C. Pick a point here, and we'll call it D. Okay? Then I'm going to come on this angle and pick a point C prime on this side,
Such that,
so that this is the same big as that, and a point on this side, call it D prime, so that this is the same big as that. Okay? And then we're going to have that this triangle ACD and this triangle A prime, C prime, D prime are congruent by side, angle, side. Because remember, A prime is as big as A. Don't really have that in here. Draw that. This angle is as big as this angle. That's how we constructed A prime. With me so far?
yep.
Okay. So then, we're going to take a point here on B prime. Namely, what letter are we at? A, B, C, D, E. E. And we know that E is in between C and D. We're guaranteed E is between C and D. How do we know E is between C and D?
Because
Angle B is less than angle A.
Yeah, it's on this ray, which we know is interior. By definition of angle B being less than angle A, anything on this ray is interior to the angle. So if I take any 2 points on the exterior of the angle, then there's a point on any ray in between them that, did I say that right?
no,
For any 2 points
exterior.
on the angle,
larger angle.
then for any ray on the interior, there's going to be a point in between those
Yeah.
2 points.
Right.
Good? Okay. So that's going to give us E prime is in between those. Now, we're going to come over here and we're going to pick a point. Oh, sorry, that was E. We're going to pick a point E prime so that this is congruent to this. Now, we're going to know that E prime is in between D prime and C prime. And the reason that we know that is we know that DE is less than DC is congruent to D prime C prime. So since this is congruent to this, and this is less than this, then this is less than this, and therefore E prime is between them.
Yeah.
Does that make sense?
Yeah.
Okay, So now we know that E prime is between them. And we know that this triangle is congruent to this triangle. Sorry, I forgot to draw an important piece of information. When we showed that ACD was congruent to A prime, C prime, D prime, that also gave us this angle congruent to this angle. So now I have this little triangle is congruent to this little triangle by side, angle, side. And so then I have angle E prime, A prime, D prime is congruent to EAD, which is B prime, is congruent to B. So since that angle in red, this red angle, is congruent to B, then they're the same angle. And so then there's a point E prime, so that means E prime is actually on B, that's in between them, and therefore is interior to it. So the whole ray is interior to that, or in other words, this ray is exterior to that. That's big picture everything we're going to do. Now we'll go through it again and we'll write out all our steps as we take them. But does it help when I do that first?
Yes. Yes.
Maybe just erase the pictures altogether. Alright. So we're starting out with some angle A and some smaller angle B. Right? So 1. Let angle A and angle B exist such that, let's see, which one do we have? Angle B is less than angle A. Okay? Angle B is less than angle A, what does that mean?
That means that there's a line on the inside.
Yeah, we can come and we can construct a ray interior to angle A such that this angle, we'll call it B prime, is congruent to angle B. Right? Then there exists some angle B prime with one side common, one side shared, I don't know, shared with angle A, comma, and one side interior to angle A. Okay? Now I'm going to move where I put my B, because I'm going to want to put my A prime there. So my next step is using this ray, construct angle A prime, so that the other ray of A prime is on the same side of this ray as the other side of B. You follow that?
No. Say that again.
I'm going to construct an angle. So using this ray, I'm going to construct an angle congruent to A, but there's two angles I can construct congruent to A using this ray. I can construct one up here and one down here. I'm going to construct the one up here. The one that's on the same side of this ray as the other side of B.
Okay.
That's what I'm saying. That makes sense?
Yes.
I wish I was more of an artist. So there's A prime. So we have this angle is congruent to this angle. So now let's put that in words. 3 construct angle A prime such that angle A is congruent to angle A prime, angle B and angle A prime share a side, and angle A and angle side on the same side. Their other side on the same side. Side of the shared side. You understand what I'm saying? It's probably a better way to write that, but if you understand what I'm saying, we're
If
good.
you label points on the other rays.
Yeah, I just didn't want to get crazy with points.
Yeah,
I didn't want to
yeah.
make my words clean for the sake and make my picture dirty. I think it's better to have the picture clean.
Okay.
But you understand what I'm saying?
Yes.
Okay. So next, what are we going to do?
You're gonna make
Point
angle
on angle A
Yeah, we're going to name 2 points on angle A,
on both rays.
call them D and E.
Why not?
Why not
C,
C and
D.
D?
Oh. Let C and D be any 2 points on opposite
angle rays
sides
of
of
angle
angle A,
A.
comma, and let C prime and D prime be points on corresponding sides of angle A prime such that, so I'm saying put those points there and come and put D prime and C prime here, so that A prime D prime is congruent to AD and A prime C prime congruent to AC. So such that AC is congruent to, not equal, congruent to A prime C prime and AD is congruent to A prime D prime. Okay?
Okay.
So now we got that, congruent to that, and now we got that, congruent to that. Now we construct
E.
our congruent triangles.
Ah.
Looking at this and this, we have congruent triangles by side, angle, side, right?
Yep.
So 5, observe triangle what? CAD, or DAC is what you're saying? DAC is congruent to triangle D prime, A prime, C prime by side, angle, side, comma, and so C prime is congruent to C. And so angle C is congruent to angle C prime. That's the reason we wanted that.
Yeah.
So we wanted this angle congruent to this angle. Okay?
Now we have to construct point E.
Well, now we say, yeah, observe that there's a point E,
And between the lines and
On.
okay, that one.
that ray, so that it's between C and D,
Okay.
right?
Yep.
6. Observe that there exists E, there exists E isn't very pretty. There exists E on angle B such that C, E, D. Good?
Yeah.
So now we're going to come,
And
let's
the
draw
angle
B
B prime,
more like this.
not angle B.
B prime, thank you. Good catch. B prime. So now we're going to come pick a point E prime here and show that E prime is actually on B.
Yeah.
Okay? So 7, let E prime on
Just
C prime D prime such that
EC prime prime.
C prime
E prime.
E prime
It's
is congruent to
EC.
EC. Okay. Now we want to say that E prime is between these 2 points. How do we know that E prime is between these 2 points?
Or if the segment EC is congruent to segment EC. Oh, no, that's not it.
This is congruent to this,
And that's.
and this big one's congruent to this big one.
Yeah.
So here's, maybe I'll write it and then I'll say it one time. Since the important relationship is, since EC is less than DC is congruent to D prime C prime,
Yeah.
comma, then EC is less than D prime C prime, and so C prime E prime D prime. Or maybe it's better as D prime E prime C prime.
Yeah.
So let's remember, what does it mean for this segment to be less than this segment?
That there's a
There's a-
point.
That there exists a point, namely E prime, such that C prime E prime is congruent to CE and C prime E prime D prime.
Right.
That's how we know it's between. So now we're guaranteed that this point is in between these two things. Last thing that remains to be done is show that it's on this ray, and we're done, right?
Yes.
Wait, though, you said EC is less than D prime C prime. Don't we need to show that E prime C prime is less than D prime C prime?
So-
to get that betweenness relation.
When I say that EC is less than this,
Yeah.
then that gives me that there is a point congruent, namely C prime E prime, and that point's between.
Okay.
So maybe splitting these two up was a bad idea. Maybe this is a more clear way to write it. Maybe say this. 7. Since EC is less than, oh, let me say CE, because I think that's what it is. CE is less than CD is congruent to C prime D prime, comma. Then there exists E prime on C prime D prime such that C prime E prime is congruent to CE and C prime E prime D prime. Is that a better way of writing that?
Yes.
Logic follows better there. Okay, so we've got this point E prime. Now what remains to show is that E prime's on that ray.
Yeah.
So now we have this side is congruent to this side. So by side, angle, side, do it in red again, so that I'm just consistent with how I explained it last time. This triangle is congruent to this triangle, which means that this angle, E prime, A prime, C prime, is congruent to B prime, is congruent to B, and so E prime, A prime, C prime is angle B, because they're on the same side. Good?
Yep.
How do we know they're on the same side? Because E prime is on the same side as C prime as D prime. And D prime was on this angle, and we constructed angle A prime to be on the same side as B. Does that make sense? And I don't want to spell all that out because I'm running out of room. So, let's see, where were we? We were saying that these two triangles are equilateral, or not equilateral, congruent, not markers. Okay. observe triangle E prime C prime A prime is congruent to ECA. It's congruent to triangle ECA. It's congruent to triangle ECA by side, angle, side. And so angle E prime, A prime, C prime
Angle B prime.
E prime, A prime, C prime is congruent to EAC, which is the same thing as B prime.
Yep.
You good with me just skipping to B prime?
Yep.
It's congruent to B prime is congruent to angle B. 9. Therefore, E prime is on angle B. 10. Therefore, angle B's other other side is interior to angle A prime 11. Therefore, angle A primes we're gonna have to write like that if I do that. Therefore, angle A primes other side is exterior to angle B. 12, therefore, angle A is greater than angle B. Yeah. Kind of messy. The book probably does a cleaner job proving it. Like I said, I don't follow exactly what they do, so probably should have on this one because we got real wordy. Anyways, there's that. So that was theorem 6.8. Theorem 6.9 and 6.10, we're not going to bother proving, we're just going to explain it real quick. So theorem 6.9 says, look, if you have two angles, either one's greater than the other, or they're both congruent, or one's less than the other. One of those three things is always true when you have two angles. Does that make sense?
Yes.
And then the other theorem gives you a bunch of stuff that you'd already just say. So it says if angle A is congruent to angle B, and angle B is less than angle C, then angle A is less than angle C.
Yeah.
And it gives you 4 more things like that. So intuitive things, now you can just think about angles how you already think about them. When it comes to less than and equal and congruent. Okay. We had one more definition. Definition 6.6, which defines an obtuse angle and an acute angle. So what's an acute angle?
Angle less than
Right, if an angle is less than a right angle, now we know what that means to be less than. If an angle is less than a right angle, it's acute. And if an angle is greater than a right angle, it's obtuse. And so I think by their definition, a straight angle is an obtuse angle. I couldn't see why it wasn't, because that's one of the first things I wondered when I read it. And then we have our last theorem. Our last theorem was actually one of Euclid's postulates, and it is that all right angles are congruent. So let's look at that.
Why does this sound like familiar? Did we do something similar to this already?
We proved that what did we prove?
I don't know.
we prove something along the lines of if a right angle,
Have to supplement.
an angle that's congruent to a right angle is also a right angle,
Oh,
I think is what we proved. That sounds right.
that makes sense.
Yeah, that's what we proved. So now this one is saying all right angles are congruent. So this is 6, 9, 6, 9.
I think it's 6, 11.
6, 11. All right angles are congruent. Okay? So, let's start this. Let's start out with 2 right angles. I won't bother writing all the words for this. I think you'll just see it. So let's say that we have a right angle A. Kind of assuming more with my picture already, but so here's a right angle A. Here's a right angle B. And maybe I'll do like roughly. Assume by way of contradiction, angle A is not congruent to angle B. So we've got angle A is a right angle B is a right angle. We can really quick throw in A prime here and throw in B prime here as our complements, right? And we know that's congruent to that. We know, maybe I'll just use different colors instead of using my color. But so for A, we'll do blue. And we know that's congruent to that. Okay. So we're going to assume by way of contradiction that these 2 angles are not congruent. Now if they're not congruent, one's greater than the other. Right? So we'll call the greater one angle A and the smaller one angle B. So here's the way that we usually say that. If it doesn't matter which one we call greater than or less than, we typically say without loss of generality. Generality. Yeah, you're right. Let angle A, should we make it bigger than or smaller than angle B? Less than angle B. Get all my things pointing the same way so it gets real confusing. Okay? So what does it mean for angle A to be less than angle B?
That you could draw a line.
Construct a B angle B prime such that.
Yeah, let's come, we'll put B here. A is less than B, which means we constructed A prime down here.
Right.
And we already used A and A prime, so I'm just going to use C. Just to help us. I'll use the blue to mark the angle. So I'm going to come down here, I'm going to draw one lesson. It has to be interior, right? And we'll call this angle C. And then we'll call its complement C prime. Okay?
Fair.
So, maybe I'll do that one in blue altogether. That way, I think it's more obvious what the green's doing. This green's like that. You see the picture I'm trying to draw?
Yep.
So we're assuming that angle A is less than angle B. So then we have this angle C down here that has one of its sides interior to these 2.
Yeah.
Good? Okay. So then we have, let's just write it all out. We have angle B is
Greater
not
than.
angle B. We have, I'm not sure how we're going to get our contradiction when we write all this out. I think it's going to be like this. Angle A is congruent to
We'll see.
angle C is less than,
Angle B
let me do my lesson better, less than angle B
is congruent to. Angle B prime.
angle B prime
Is
Which
congruent
is less
to.
than.
is less than
Is.
C prime.
angle C prime
Oh, I didn't see.
is
C
congruent to
Congruent to
A prime
A prime.
is
Greater than.
congruent to
Oh.
angle A. And there we go. We got angle A is less than angle A. Contradiction.
Wait, what? Oh.
Angle A, which is congruent to that, is less than that, is less than that, is congruent to that.
Oh.
So we ultimately got angle A is less than angle A. Contradiction. Angle A is not less than angle A. So our assumption is wrong. So the two are congruent.
Not gonna draw the contradiction symbol.
No, because this isn't a proof. This is me talking, and you guys hopefully understanding as I'm talking.
We get it.
Yeah.
All right. You get it?
Yeah.
All right. So, Mamie, you want to come up and redo this proof?
Yeah.
Too bad.
I wasn't going anywhere. I knew you'd say that.
Oh yeah.
Yeah, I knew you'd say sit down.
Wow, you're really pushing to have. You're really pushing me to have you do it. You must really want to do it. Okay. And that is the end of chapter 6.
So, that's the new class.
Huh?
Gonna fall asleep.
I wanted to push through chapter 7.
We can do homework. Homework.
How many of you did chapter 6 homework? You're the only one. Emma didn't do it.
Emma!
Oh, shoot.
Hold.
My one good student. Just like that. Huh?
I said the standard has been lowered.
No! The standard has not been lowered. It's just another one bites the dust.
And what bites the dust?
Standards.
The standard's still high. It's so high that everyone's in the dust compared to it.
Another one bites the dust.
All right. Chapter 7. Moving on with congruencies. All right. Do you feel like you've already had way too much information? It's just can't go forward.
That's like overload.
All right.
overload.
Your brain is full, just push stuff around in space.
I wanted to. I'm worried we're not going to get through the book before school starts. That's my concern.
School starts in
School starts
August.
September?
August.
7 months.
Because
15 chapters.
well, we skipped the first 20 pages. So we're now on page 117. So we've basically gone through 100 pages in 6 classes.
Oh, I see what you're saying.
So in 6 more classes, we go another 100 pages.
Yeah, but
And
we
that still
also-
doesn't get us to the
we
end of the
missed
book.
a week.
Huh?
We missed.
16 chapters.
No, I'm counting only when I've lectured on the actual book material. Has been 6 times.
Yeah, I'm saying we missed a week.
Nice.
Oh.
No.
Oh, okay.
There's been 8 classes total,
See what you're
6
saying?
lecture classes.
Okay.
How's that?
Yeah.
Okay. So you just want to do homework problems? All right, let's do some homework problems.
Wait, how many chapters are in the book?
Yeah, I think there's 15 or 16, but not all chapters are created equal. So the more relevant number is, I think there's roughly 260 pages of material. 275 pages of material.
We should just move on.
Yeah, but there's no point getting through all the material if you lose people halfway through the material. Right, Deborah? Agreed. Well, if you do your homework, then when you see the stuff on the board, you will have used it so many times, explaining it's just a waste of your time, and we just move on with our lives. And if you beat a class on time. Okay, so let's go over any homework problems. Pick a problem. Pick a problem, any problem.
6 to 4.
Give me a page first.
I don't know. I'm gonna find it.
Chapter 6.
It's 85.
85. Going back to 85. Whoa, right in the beginning.
Yep.
Okay, what number?
4 on 6 2.
4. So if in figure 6-4, A is a straight angle and R prime is a ray from...
No. 6 2, problem 4.
Oh,
If it figures
use postulate 5-1, B and C, and B and C of postulate 5-2 to prove every angle A, prove that for every angle A is congruent to angle A.
Where are you?
Yeah, where are you?
Oh, I
Page
found it.
85.
Page 85.
At the
Very
bottom.
bottom.
Weren't we already given that congruence is reflexive?
Yeah.
That's a good question.
So, let's see. Using postulate 5.1 and B and C of postulate 5.2. So what's postulate 5.1?
Means you can
If A is a
use
straight
that.
angle, we can construct two angles so that they're congruent. And then B and C. Oh, that's easy. So they're basically saying, okay, we're going to take away
The reflexive property.
the reflexive property and now still try and prove it. Okay? So here's some angle A, right? We know from the first postulate that we can, using this ray, construct some other angle down here, B, congruent to it.
Yep.
Now, if angle B is congruent to
Angle A.
angle A, and by the reflexive property, let me write that the other way. We know that angle A is congruent to angle B, right? And we know that by the reflexive property, angle B is congruent to, not reflexive, symmetric, sorry, B is congruent to angle A. Then using transitivity, angle A is congruent to angle B is congruent to angle A. You follow the logic there?
Yeah.
It basically tells you exactly how to do it. It says, look, use your very first postulate, and that tells us we can do this. Use B, all right, there's using B. And now use C, all right, there's using C. And you're done. Any other ones?
Yes. I could figure out how to do number 3 for exercise group 6.5.
6.5.3.
What page? It's page 8.
Draw a figure to show that AB congruent to A prime B prime. Am I reading the right one?
Yeah.
Maybe it'd be easier to just have you guys read these to me rather than me trying to draw them. So, what does it say?
So draw figures to show that AB is congruent to A prime B prime. And angle A is congruent to angle A prime. But angle C is not congruent to angle A prime C prime. Or not, AC is not congruent to A prime C prime.
No, just A. No, it's
But
AC.
So I've got triangles. Let's see. So I've got A, and I've got B, and I've got A prime, and I've got B prime. That's congruent to that, right?
Yes.
And I have to do angle A congruent to angle A prime.
It goes on. So then it would not be true that angle C is congruent to angle C prime. That's what we're trying to say.
Angle C is not necessarily congruent to angle C prime.
Yeah.
Picture's good.
So,
Now just make AC and AC.
yeah, I can just pick C there, and I can pick C prime there.
CU.
Does that not work?
Yeah, it does. It works.
Is that all it was asking for?
Don't.
Draw figures to show that if AB is congruent to A prime B prime, and A is congruent to A, and angle A is congruent to angle A prime, but AC is not congruent to A prime C prime, then it need not be true that angle C is congruent to angle C prime.
That is not true. Why do they think it need not be?
Is there a way to make it true?
There's no one.
Wait, do we have to prove what they're saying or just show?
No, it just says show with figures.
Oh, okay.
But yeah, now there's a more interesting question. Is there a way to make those equal?
No.
Just so that
So-
angle equal.
What if we did that equal to that?
Then it's the same triangle, Donnie. Side angle side.
No, you still don't have it.
Side angle side to side angle.
That's not even.
Yeah, you can't just call two different triangles.
Oh, well.
different.
We answered what the question was, too.
No, we didn't say that.
I'll have to think about that better. That's a more interesting question, I think. Are you raising your hand for one?
I was just wondering what contrapositive means again.
Contrapositive. So, if A implies B, what's the contrapositive?
Not B implies not A.
Perfect. Not B implies not A. And they're logically equivalent.
So,
James plays football implies James is wearing shoes is logically equivalent to James is not wearing shoes implies James is not playing football.
okay, so if the theorem is true, is its contrapositive true?
Yes.
They're logically equivalent.
Because if a theorem is false, then I'm having a hard time seeing that.
These are logically equivalent?
No, like,
A theorem is
This-
two parts, James.
This is a theorem. A implies B. That's a theorem.
so if it's
All theorems are of the form or can be reworked into the form if A, then B. Name any theorem you know.
sky is blue.
That's not a theorem. Name any math theorem you know.
Oh, a squared equals 4.
Pythagorean theorem. So what's Pythagorean theorem? If you have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. It's an if-then. Any math theorem you have out there, it can be stated in an if-then statement. Every math theorem is a logical implication because deductive reasoning is using logical implications. All the reasoning that we use in mathematics is deductive reasoning. It's all we use. Every conclusion we come to is a logical implication. Our postulates give us our starting A's, and then we do A implies B, implies C, implies, and we keep going with it. Or we use combinations. If I have A, B, and C as postulates, I might use B instantly gives me D, maybe D and C together give me E, and I keep building out this big web of math. That's what we're doing. But we're always using deductive reasoning. We're always looking for the logical implication of what we're talking about.
Okay.
Starting with some postulates or axioms.
Something popped up on your phone.
It's low battery.
Should be charging.
And it's charging now.
Oh well. And if it dies, it dies. We're just going over extra credit problems now. Or not extra credit, homework.
There's a true or false test on page 114.
114. Want to do some true or false questions?
Yes.
Yeah, that's true. I could just start quizzing you on the review. Alright, so yeah, let's just do some review stuff. Question number 1. Miriam,
Yes, ma'am.
don't answer this. If a theorem is true, its contrapositive is true. True or false?
True.
It's true.
We are on page 114. We're going over the test, I guess, is what this is.
You literally told me not to answer it.
Yeah. It's because you were talking in my class and you don't deserve to talk anymore. You used up all your talking points. You don't get to answer any of these questions. Alright, next.
Your minutes are out.
The supplement of a 40-degree angle is a 50-degree angle.
False.
True. It's false, you guys.
Man.
What do you mean? Together they create a right angle. That's a supplement angle, right?
No.
Oh, those are complement angles. Okay. Supplement angles produce 180 degrees, which I don't like them saying here because we haven't talked about degrees yet. They produce a straight angle. Alright, we're not doing any ones with degrees. 4. If B is between A and C, and E is between D and F, and AC is congruent to DF, and AB is greater than DE, then BC is greater than EF.
So confusing.
So let's draw a picture.
Let's drop it through.
TDF.
Okay.
Yeah, will you just read it to me real quick?
If ABC,
So A, B, C,
D, E, F, such that AC and DF are
D, E,
congruent.
F, such that which?
AC and DF are congruent.
A, C, I'll just circle it, say the whole segment. That whole segment's congruent to that whole segment.
Not
No.
the larger segments.
It's A and C. A, C, and D, D, F.
Yeah, that's what I'm saying.
Oh.
That's what my circle meant. This is congruent to this. I was using circle to say the whole thing, and then I was going to use ticks to say the parts. But oh well. Keep going.
And AB is greater than DE.
And this is greater than this.
Yes.
Then BC is greater than EF.
So there's E. So if this is greater than this, then this is less than this, or this is greater than this. Right? Okay.
No,
Wait,
it's
what?
back.
What? Then BC is greater than EF. No, that's wrong.
So here's the picture.
EF is
This whole thing is the same big as this whole thing.
Okay,
AB is greater than DE.
yeah.
Therefore, BC is less than EF.
Yeah.
Or EF is greater than BC.
That means
Yes.
this is false.
Okay, so it's false.
Yeah.
I wasn't reading that, I was just saying what was.
I was AB.
Okay, next. If ABC is an isosceles triangles with vertex A and D and E,
Are the midpoints.
D, D are the midpoints.
AC respectively.
with
DE are the
vertex
midpoints.
A, and D and E are the midpoints of AB and AC respectively, then BE is congruent to CD. So, let's get a picture of what that's saying.
Oh.
Yeah, that's not very good verbiage. So we're saying we have isosceles triangle A, B, C. When he says A is the vertex, he means it's the top, and these are the two sides that are congruent. Okay? And then what do you call the midpoints? So D and E are the midpoints, which means that's congruent to that, and that's congruent to that.
Okay, but that's not what he's asking.
What does he ask?
DE congruent to DC.
Is BE congruent to DC? Oh.
Yes,
Is this and this congruent?
Yes.
Yes. We know that that angle is congruent to that angle, and the bottom is congruent to itself. So this triangle, do, is congruent to this triangle, do.
You realize angle side angle is angle.
Right side.
The red triangle
So angle side angle.
So side angle.
is congruent with the blue triangle. By side, angle, side. Side, angle, side.
Oh.
So their hypotenuses are here. They're not hypotenuses, but both sides. Good? All right. Next.
Triangles ABC and ABC prime.
Where are you reading?
No, what are you reading? Say this is triangle.
Am I reading the wrong one?
No, you're not.
6. If it triangles ABC and A prime, B prime, C prime, A is congruent to A prime, B is congruent to B prime, C is congruent to C prime, and AB is congruent to A prime, C prime, then the two triangles are congruent?
No.
No! The order is wrong, right?
Right.
In fact, those might not even be congruent at all.
They are?
They have to be congruent. They have two angles and a side in common. So yeah, the ordering is wrong on how he's listing those, right?
Right.
That's weird.
Should we draw that one out and see what exactly it gives us?
Maybe they are.
They might be congruent, but not the way that he gave it to us,
No.
unless they're equilateral. So, let's see. So we've got
ABC.
So we've
All
got
three. Oh, shoot.
that's congruent to that. We've got that's congruent to that. And we've got that is congruent to that. And we've got that is congruent to like that.
Yeah. So it could be a scaled down version. Or it's equilateral.
Yeah, you're right. It's could be a scaled version. So that doesn't mean they're congruent. Right? Everyone understand that those triangles aren't necessarily congruent? That's a test question. Did you read what it said at the top? Test 1. We're doing a test right now. You're all failing? Alright. You're okay with that. Enjoy being in the dust. Never want to meet those expectations.
Why are we telling?
Because you didn't.
Because you're not answering right.
I answered that one right.
Those actually are the same triangle.
Not necessarily.
Just because you drew them different doesn't mean that they're not congruent.
How are they congruent? Alright, Mim's going to prove that these are congruent.
Fun.
If those two sides are congruent, then they look like that. And if that angle is congruent with, let me write this the right way.
Yeah, you might want to label some points so you do it, right?
Okay,
So call that
What's
A,
this?
B, C. You have to label that A prime, B prime, C prime.
We didn't
Because
even
those are
like
the
angle,
angles.
angle.
okay. Well, that's a
Is there
different
even
story.
angle?
That's a different story.
Angle,
Donald.
angle, angle, that doesn't mean congruence.
That's a
It means
different
similar.
story, Donald.
Why does it matter how we label
I
it?
guess it's fine, whatever. I'll do it my way. Let me think.
So you got A, B over there,
Okay.
and A prime, C prime over here.
Okay. Now, I can't think why I don't do this. I'm gonna draw the same.
Did you know that C went over there?
Yeah.
Smart.
Let me think about it.
Then congruent lines don't have to go the same direction.
How do you know they're congruent then?
No. Okay, I don't need to draw these, but I need to show you that.
This?
Yeah.
Yeah?
If that is congruent with that,
Yeah.
Get your
Then you
yardstick
just
out.
erase the picture and draw better.
yeah.
The picture lies. You should be able to prove it regardless. And it was only one tick.
One.
Oh, it was two.
Okay, then do 2.
Oh,
on
this one? I thought you were saying that. Then it's literally just turn
And
that
wrong,
way.
and wrong.
Listen, those are the same. Those are congruent. If
Now-
this is all true.
Let me make it obvious that these aren't congruent. And we'll draw it out to make it all nice and pretty.
They have to be.
I'll draw a scenario.
Oh,
that makes
never
it
mind. I
obvious.
went through the same thing in 9th grade. Never mind. I changed my mind.
You realize you're way wrong?
I changed my mind.
So this
4,
is 30
5,
There's
centimeters.
no
6.
such thing as angle.
So I'll do 6.
Oh.
Angle, side, angle.
They weren't the same
Let
angle.
me- And then connect those.
Donnie, you're right. I already know.
And then, let's see. I need 12.
Do you want?
I take my time inside my mind. Think of the grumpiest old man.
Okay.
That's not even what you do.
I can't do it.
Do what?
Do it.
These things sound like funny when I do it. You see it? Makes Debbie laugh every time. I don't know why.
Alright. There is an example of why this isn't true. That should be pretty obvious to your intuition. I've drawn these triangles so that that side's the same long as that side. Those angles are the same, those angles are the same, those angles are the same. Those triangles are congruent.
They're similar.
Oh, so I guess they're not congruent.
No.
Similar triangles can be congruent.
Yeah, you're right.
There we go. Alright, any other questions?
No.
No more homework questions?
No,
Well, we're not.
It was all just too easy?
there's some more.
Oh, we were going over test questions, huh?
Yeah.
All right. We did that one.
So 9 and 10.
Yeah, skip angles. If segment AB and CD intersect at O, then angle AOB is congruent to angle BOD. So we've got AB,
That is not true.
and what was the other one? CD intersect at O. And what's the angles we're talking about?
AOB and BOD.
BOD?
Yes.
That's obviously not true.
What's wrong with it?
You have a
AOB
non-straight
is
angle
straight
compared to
angle.
a straight angle.
Right, one of those, unless these lines are collinear and actually the same exact segment, then it's not going to be true, right?
But they can't be that, because they intersect at one point.
At only one point?
Oh.
Yeah, assuming that they only intersect at one point like this, then a straight angle is always greater than a non-straight angle, and therefore
False.
this can't be true. Because an angle is either greater than another angle, or congruent, or less than. It has to be one of those three.
Right.
And so if it's greater than, it can't be congruent. All right. For all statements alpha, beta, gamma, such that alpha implies beta is true and beta implies gamma is false, alpha implies gamma is false.
Alpha implies beta. True. Beta implies gamma. False.
So if you're getting lost in the verbiage of this, it's real easy to just throw it up in the truth table.
Yeah.
Yeah, but that's cheating.
Alpha, beta, gamma. We have true, 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 false, 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 false. We have true, true, false, false, true, true, false, false, and finally alternating true, false, true, false, true, false, true, false. Now, we were doing alpha implies beta.
It's true. Or was true.
True.
So alpha implies beta. True.
True. False. False. True.
True.
True. True.
And then we need, was it beta implies gamma?
Yeah.
Is it gamma or amma?
Gamma. Beta implies gamma.
True.
False.
False.
True.
True. True.
False.
True. False. True. False.
No, we made a mistake.
True, true, or false, false.
Beta implies gamma.
Lol.
Or false, right?
What?
We're missing.
That one is false. Wait.
What the heck? True, true, false, false. True, 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 true. Oh, sorry. True,
False.
false,
True.
true, 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 false, true.
True. No, false.
Oh, that's because this is supposed to be false. Which means this is true. Okay. And finally, what's the last one?
Alpha.
Alpha, gamma.
Gamma.
Yo, gamma, gamma.
True. False. True. False. True. 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 All right. So there's our truth table. Huh?
No, that wasn't the last one.
What's the last one?
If beta implies gamma.
Yeah. So if beta implies gamma, hold on. If alpha implies beta is true, So if
Wait,
alpha implies beta is
in
true.
those two scenarios,
So
those
far we're talking about here, here,
here.
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 Let's
Just put a
let's
line
put a
through it.
line through what we're not talking about. So we're saying if alpha implies beta is true, which takes out this case and this case. That goes through this.
And beta implies gamma.
And beta implies gamma is
False.
false. So now we're only talking about this case
Actually, there's another one out there.
and this case.
What?
There's only 2 cases.
So there's only 2 cases that we're talking about.
It could be false or true.
Alpha.
And it can be false or true.
They're both. It's neither
So-
false nor true.
So it's true when alpha is false.
So if alpha and beta,
False when alpha is true.
well, if this implication is true,
That doesn't make sense. They should both
And
be
that
false.
implication is false.
they should both be false.
Why should they both be false?
Oh no.
Look at this case right here.
Yeah, never mind.
I mean, we can just flat out think about it if we don't like that we get table.
Okay,
So false implies true is true. True implies false is
False.
false implies false is
True.
Good job.
So
Alright.
which one are we
So it's
looking at?
neither false nor true.
well, what does the question
The
say?
statement is false.
Oh yeah, it's false.
So whatever the statement is, it's false. My book keeps closing. Okay.
True.
Any other problems you want to go over?
Gross.
Yeah, no, maybe. You tired? You sleepy? Had a long day?
Yeah.
Oh, you poor things.
All the above.
All right.
And we appreciate it.
That's